Hello everyone, welcome back to lesson 15 for Calculus AB, where we're talking about how to do basic antiderivatives. In the first video we just talked about simple polynomials, and now we're going to talk about some simple polynomials raised to a power, and then how to integrate very simply some simplistic rational functions. So if you guys look at this integration right here, so we're going to integrate 2x minus 3 quantity squared dx. Now, there's a concept we're going to learn a little bit later on called U substitution. That's the suggestion to do that. But right now, since we don't know how to do U substitution, then what we're going to do here is just simply go ahead and expand. All right, so we're going to go ahead and expand this by foiling. So this is really just going to be 2x minus 3 times 2x minus 3 dx. And so let's go ahead and again, by the way, keep the notation right? So we're simplifying this. We need to make sure we're still writing the integration and we're always putting the dx. So that's really, really important. We just can't just go ahead and simplify this without the integration and the dx. So be very careful about the notation with this. So we're going to go ahead and multiply these out. And so let's just go ahead and just do what we normally do because we know how to fold this. We're calculus kids, right? So 2x squared is just going to be 4x squared. And then we're going to multiply and we're going to double. So we're going to get negative 6x, so we're going to double that to 12x. Well, negative 12x. And then negative 3 quantity squared is going to be 9. And again, guys, please don't forget your dx. It's really, really important to write the dx out. Okay? All right, and now once we get to this, now we're back to what we learned in the previous video. So we're going to do basic integration. So we're going to leave the 4 alone for now. We're going to write x. We're going to add 1 to the exponent, which is 3, and then whatever this exponent is, we're going to put it right here in the bottom. And then we're going to do minus, and we're going to do 12. Again, leave the 12 alone. We're going to do x. We're going to put 1 more, so 1 plus 1 is 2. We're going to keep adding 1 to the exponent, again, as we did in the first video. We're going to plop down our exponent here as 2. And guys, we've hopefully learned now that the integration of a constant is just going to be that constant, and then we're going to plop on an x. Because remember, the derivative of 9x is just simply 9. Plus c. And so this is actually the answer, and if we wanted to rewrite it, we could as 4/3, and this is fine, okay, this is totally fine, but 4/3 x cubed, this is going to be minus 6x squared plus 9x plus c, and usually for multiple choice questions, they will have it simplified for you, okay, but again, in an FRQ or anything like that, you guys can leave it alone. So that's that first example. So anytime you see this, again, you guys will see examples where this is like to the 12th power or the 15th power, and then you're not going to want to expand it that many times, so therefore you're going to use U substitution, which we will get to in a future lesson. All right, so what about question number 2? So this one right here. Now, we cannot, just like before, we cannot, if I was to ask you guys to find the derivative of this, you cannot take the derivative top and then independently take the derivative bottom and call it a day. So you cannot integrate the top separately from the bottom. You can only do that when functions are being added together or divided by, added or subtracted from one another. So for this one, sometimes you have to think strategies. Now again, U substitution may be something that we would do here, but we haven't learned that. So what we can do is we can split it, right? I have actually taught you guys, if I were to ask you to find the derivative of this, I said, oh, let's rewrite this first. So let's rewrite it. So again, we're going to keep our notation fine, and I'm going to show you every little step, because that's what I do. So I'm going to go ahead and split so what do I mean by split? I'm going to split the numerator, right? I'm going to split it up. So we're going to split the numerator up, and so we're going to just have them all under x plus 4, or x over 4. If I were to get a common fraction, right, if I get a common fraction, I would get this back. Right, we all know that 3/5 plus 2/5 is equal to 5/5. Well, that's exactly what we did right here. We just split it apart. And then we're going to simplify. All right, we're going to simplify a little bit. So we're going to go ahead and do x squared over x to the 4th. It's going to be 1 over x squared. And then we're going to do 3 over x cubed. Right, just go ahead and cancel the x and 1 of the x in the denominator. And then we're going to leave the 1 over x to the 4th here, dx, because we want to be able to integrate. And so now from that, we're going to rewrite. So let's bring this up to the top. So 1 over x squared is just really x to the negative 2. We have a 3x to the negative 3. And then we have x to the negative 4 dx. Okay? And now, just like on the previous video, what we did is we're going to integrate these problems. Again, ladies and gentlemen, especially with the negatives, remember we are adding to the exponents, right? We're adding, just like we did in the example above. We add, so just be very, very, very careful when you guys are doing negative exponents. So it's -2 plus 1 is -1, and just like before, we're going to plop down our problem here. We're going to leave 3 alone. X2, again, -3 plus 1 is -2. And then again, whatever this is down here. And then plus x to the -4 plus 1 is -3. And then we're going to plop down our -3 right here. And then don't forget our plus c. All right? So when all is said and done with this question, we're going to have -1 over x. And then we're going to have a -3 over 2x squared. All right, so just rewriting. So I brought the negative out and to do a 3, and this goes down with the 2. And then I got another negative. And then I've got 1 in the top. And then I got a 3x cubed in the bottom. Plus c. Plus c. Okay? So that's 2 strategies. Foiling it out and simplifying by splitting your numerator. Those are 2 ways that you guys can do the problems. And sometimes that's really helpful for us to do. I'm not going to show you guys, we're not going to finish this right here, but sometimes, and I would imagine this being something that you would be assessed on by any means, but you know, sometimes they may give you something this crazy, and so you would want to just verify that you can do this. So we're just going to set this one up, and then we're going to call it a day on this video. But you guys can see here that we have 2x and 3x, so we would FOIL this as 6x squared. We would have minus 15x plus 4x is minus 11x. And then -5 times 2 is going to be plus 10. So we would FOIL this first, and then this is to the 1/2 power, right? So this is the 1/2 power. So we'd have 6x squared to x to the 1/2 power minus 11x to x to the 1/2 power plus 10 over x to the 1/2 power dx. And then just to simplify this, we would have 6x to the 2, and this is going to be minus 1/2. So it's going to be to the 3/2 power, right? So this is really just 2 minus 1/2, right? I move it up, it's 2 minus 1/2, which is 3/2 power. And then we're going to get 11, and then we're going to get x, move this up to the 1/2 power, and then we're going to get 10. We're going to move this up, we're going to get x to the -1/2, and why not just finish it, right? We're pretty much done with it now anyways. So let's go ahead and knock this thing out. But again, I just want you guys to know that I fold the top, right? I fold the top, and then I split it up. I split up all my pieces, and then I went ahead and just used powers of exponents, right? So x to the a over x to the b is really x to the a minus b. So I took 2 minus 1/2. This is x to the first, so 1 minus 1/2. And then this is x technically to the 0, right? X to 0, 0 minus 1/2 is -1/2. So when we integrate this problem, all right, when we integrate the question, so let's go ahead and put ourselves a little box because this is what we're going to do for this one. So again, we're going to leave the constant alone. And so this is why I'm going to show this to you guys. So I'm going to do 6x, and then so I'm going to add 1 to my exponent, which is going to be 5/2. And so I don't think I've done this yet. So since I'm going to divide by 5/2, I'm going to multiply by 2/5. I always do that. I always do it that way. I'm going to do 11. Again, I'm going to add 1 to the exponent, so this is going to be 3. Oh, actually, hold on. Let's do a little space here for us. So I'm going to do 11 x to the 3/2. So I'm going to multiply by 2/3. And then I'm going to do plus 10x. And again, I'm going to add 1. I'm going to add 1 to the exponent, which is 1/2. So I'm going to go ahead, and goodness, with my spacing here. So sorry, guys. I'm going to go ahead and I would divide by 1/2, right? But then you'd essentially multiply by 2. And then you'd have your plus c. So finally, writing this down, this answer would be, I know it's so messy, I'm so sorry with all this space. I wasn't planning on doing it, but whatever. So I get 12 over 5, x to the 5/2 power. I'm going to get minus 22 over 3, x to the 3/2 power, plus 20, x to the 1/2 power, plus c. So again, you guys can see that's a lot of work for a question where, yeah, we don't really expect you guys to do something that extreme. So one or the other is pretty much good in my book here. Okay? And if we had you guys integrate something times something else, right? Then you'd want to, if you can, you want to be able to multiply this together and then integrate it by our little power rule thing. Okay, so that's the second video. I hope that's helpful for you guys. We'll come back and we'll see you guys in the last video.